Okay, and in continuation to the previous video, and the problem 6 is in what volume ratio of 1 molar ammonium chloride and ammonium hydroxide is mixed to produce a buffer solution with pH 9.8, pH 9.8. So, by reading this problem, I came to understand that it is a basic buffer, and they given that pH. We can calculate the, for basic buffer we have a formula, that is POH. POH is equal to pKb plus log concentration of salt by log concentration of base, log concentration of base. But we do not know the POH value, but we can write the we can get the POH value from pH value, that is pH plus POH is equal to, we know that pH plus POH is equal to 14, and POH is equal to 14 minus 9.8. okay, it is 4.2, it is 4.2 10 4.2. so POH is 4.2, POH is 4.2, and pKb is what is the pKb? 4.74 is the pKb. And what we what they asked to calculate, volume ratio of salt and base, volume ratio of salt and base. Okay, they asked to calculate the volume ratio, but formula is we have the formula in concentrations. Okay, no, we do not have the formula, we do not know the volume ratios from this formula. Okay, na? So we can write this formula as concentration of salt by, okay, concentration of base into volume of salt by volume of base, volume of base. We can write this as like this, okay, because concentration of salt is molarity into volume, that gives millimoles or moles. Okay, millimoles or moles. If the given volume is in ml, that gives millimoles. If the given volume is in liters, that gives moles. Okay, concentration of base into volume of base. Okay, so 4.74 plus log concentration of salt is 1 molar ammonium chloride and 1 molar ammonium hydroxide. Their concentrations are 1 molar. Okay, but they asked to calculate the volume ratio, ante volume of salt by volume of base, 1 by 1, that is 1. So that gives 4.74 log volume of salt by volume of base. Okay, they asked to calculate the ratio of salt by base, ratio of salt by base. So this is here is 4.2, and we can write this 4.2 minus 4.74 is equal to log volume of salt by volume of base, volume of salt by volume of base. This gives 4.2 minus 4.74, it is 4.74, and it is 4.2, it is 7 minus 2, 0.54. Okay, so it gives 0.54 minus 0.54, and is equal to log 4.74 minus 4.2, 0.54. Okay, 0.54. Okay, 0.54. So log volume of salt by volume of base. It can be written as when we multiply the equation with the negative sign, that gives 0.54 is equal to log volume of base by volume of salt. Okay na, and again volume of base is equal to volume of salt is anti-logarithm of 0.54, anti-logarithm of 0.54. Okay, we can write this as 0.5 plus 0.04. Okay, volume of base by volume of salt. So 10 power 0.5 anti-logarithm, and this can be written as 10 power 0.5 into 10 power 0.04 is equal to volume base by volume of salt. 10 power anti-logarithm of 10 power 0.5 is that value is 3.16. That value is 3.16 and its value is 1.09. It gives volume by volume of salt. Multiplication of these two values that gives 3.5. That gives 3.5. So volume ratio is volume of base by volume of salt. So from this volume of base by volume of salt is 3.5 by 1. 3.5 by 1, but they asked to calculate the volume ratio of salt and base, volume salt and base. So volume ratio of salt and base is 1 by 3.5. So that is ratio is 1.35. Ratio of salt and base is 1:3.5. Okay, and the problem 7 is calculate the pH of solution obtained by mixing of 7.5 grams of sodium acetate and 5 grams of acetic acid, and given that pK of acetic acid is 4.74. So by reading this problem, I came to know that it is a acidic buffer. Acidic buffer. So it is a acidic buffer. So acidic buffer pH is equal to pKa plus log concentration of salt by log concentration of acid. Log concentration of acid. Okay, now we can write this formula as pKa plus log concentration of salt or normality of number of moles of salt. Okay, number of moles of salt is equal to concentration of salt. Okay, so concentration of salt, already I told you in the earlier classes, okay, chemical compounds are used to expressed in and they are being quantified in moles, and their concentration is being quantified in moles. So concentration of salt is equal to number of moles of salt. So number of moles of salt by number of moles of acid, number of moles of acid, and it is equal to pH. Okay, so we shall calculate the what they asked to calculate the pH, but they given that 7.5 grams of sodium acetate. Sodium acetate is a salt. Sodium acetate is a salt, and 5 grams of acetic acid, it is a acid. Okay, now we can calculate the number of moles by dividing the weight of salt by its molecular weight, by dividing the weight of salt by its molecular weight. Okay, so that gives the number of moles of salt. Then we can substitute that number of moles in this equation, and number of moles of acid. How can we calculate the number of moles of acid? By dividing its weight with its molecular weight, we can get the number of moles of acid. Okay, so pKa is equal to pKa. What is the pKa value that given is they given that pKa value is 4.74 plus log number of moles of salt. Number of moles of salt, this can be obtained by weight by molecular weight. What is the weight of the salt? 7.5, and its molecular weight is 82. Sodium acetate molecular weight is 82. Okay, and weight of acetic acid is 5 and its molecular weight is 60. So in the next step, 4.74 log 7.5 by 82 into 60 by 5. Okay, this can be 12,560. Okay, 3 fours 12 and 41 fours 82. Sorry. Okay. 6 2's 12 and 41 2's 82. So that gives 4.74 plus log 7.5 into 6 by 41. Okay, so 41. So then the next step 4.74 plus log 7.5 into 6, it gives 45 by 41. So 4.74 log 45 by 41, that is the fraction which comes out to be 40 by 41, that gives 1.09, which comes out to be 1.09. So 4.74 and log 1.09, which comes out to be 0.0. Actually log 1 is 0, but log 1.01, that's value is 0.04. Okay, so its value is 4.74 plus 0.04, that is 4.78. So 4 points, pH is 4.78. So in this way we can calculate the pH when the weights are given. Okay, when the weights are given, we should write this formula in number of moles, and if we divide the weight of the given substances with their molecular weights, that gives number of moles. Okay, so pH is equal to 4.78. Pause. Okay, before going to next problem, we should know these formulas, that is buffer capacity. Beta is the letter which is used to represent the buffer capacity, and buffer capacity, maximum buffer capacity, we can calculate the maximum buffer capacity with this formula. So the formula is 2.303 into concentration of a buffer by 4. Okay, with this formula we can calculate the buffer capacity of a buffer, the maximum capacity of a buffer solution. Okay na, so it is very important formula. Okay, and the another most important formula is buffer capacity of a solution of a strong acid or a strong base at any pH. At any pH. Actually, we know the buffer capacity. The formula for buffer capacity is number of moles of, what is the buffer capacity? Number of moles of acid or base that causes the change in pH of a buffer, 1 liter buffer solution to 1 unit. So we know the conventional formula of buffer capacity, that is number of moles of strong acid or a strong base by change in pH. This is the conventional formula for calculating the buffer capacity. But if we give the buffer solution of if we give the strong acid solution of at any pH, if they given that pH of a strong acid or a pH of strong base, then if they ask to calculate the buffer capacity, then the direct formula is 2.303 into concentration of H plus plus concentration of OH minus. This is very important formula. Okay na? This is the conventional formula. This is the conventional formula to calculate the buffer capacity. But when they ask to calculate the buffer capacity of a solution of strong acid or strong base at any pH, then the formula for calculating the buffer capacity is 2.303 into concentration of H plus plus concentration of OH minus ion. Okay, and the problem 8 is calculate the buffer capacity of an HCl solution having pH 2. So this is the problem based on the formula that is given in the 2 minutes before. Okay, so for calculating, for solving this problem, I already given the formula to solve this problem. So that formula is buffer capacity. So buffer capacity when they ask to calculate the buffer capacity of a strong acid solution of at a given pH, then the formula is buffer capacity is equal to 2.303 into concentration of H plus ions plus concentration of OH minus ions. So, they given that pH is 2, pH is 2. So, pH 2 means concentration of H plus ions is 10 power minus 2. Okay, when concentration of H plus ions are 10 power minus 2, what is the concentration of OH minus ions? Because concentration of H plus ions into concentration of OH minus ions is equal to 10 power minus 14. So, concentration of H plus ions is 10 power minus 2 and the concentration of OH minus ions is 10 power minus 12. So, buffer capacity is equal to 2.303 into concentration of H plus ions, that is 10 power minus 2, and concentration of OH minus is 10 power minus 12. Okay, so 2.303 into concentration of 10 power minus 2, that is 1 by 100. 1 by 100 we can write it as 0.01, but 10 power minus 12, that is 0.11 zeros 1 2. 11 zeros 1 to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2. Okay, which is very negligible value, so that we can neglect that value. So 2.303 into 0.01, that is which comes out to be 0.023. So, buffer capacity is 0.023. Okay, and the problem 9 is the pH of a buffer solution is 4.745. Okay, so the pH of a buffer solution is 4.745. When 0.01 molar NaOH is added to 1 liter of it, the pH changes to 4.832. So, calculate the buffer capacity. Okay, here the when 0.01 molar NaOH is added, the initial pH of the buffer solution is 4.745. So, initial pH of the buffer solution is 4.745. But when they add 0.01 molar NaOH to 1 liter of that buffer solution, that pH changes to 4.832. So, pH change is 4.832 minus 4.745, and the number of moles of strong base, NaOH is a strong base. So, number of moles of strong base is 0.01. So, buffer capacity we know, when we know the number of moles of strong acid that is being added and the change in pH, there is a conventional formula to calculate the buffer capacity, that is number of moles of strong acid or number of moles of strong base by change in pH. So, number of moles of strong base here the added is 0.01 and the change in pH. So, initial pH is final pH is 4.832 and 7.45. Okay, so 0.01 by it is 0.01, it comes out to be 0.087. Okay, it can be written as, when we multiply this 1000 by 1000, it gives 10 by 87. Okay, which comes out to be 10 by 87, which comes out to be 0.015. So, buffer capacity is 0.115. So, in order to decrease the video length, I I give the direct answer for that fractions. Okay. Okay, and the problem 10 is and this is the last problem. So problem 10 is what is the pH of a buffer solution when 0.2 molar HCl is added to 1 liter of solution containing 1 molar acetic acid and sodium acetate. Okay, and assume that the total volume is 1 liter, and given that the pKa of acetic acid is 4.747. Okay, so by reading this problem I came to know that it is a acidic buffer. For this acidic buffer, okay, this is the acidic buffer, it is a weak acid and it is a sodium acetate acidic buffer. Okay, what they asked to calculate the they asked to calculate the pH of a buffer solution, pH of a buffer solution when 0.2 molar HCl is added. Okay, already I told you that I told you this concept, and I had given the mnemonics for this change in pH. Change in pH of buffer solutions. Okay, I had explained the concept, this concept in change in pH of buffer solutions, where I was given mnemonics that AAA, ABS, BBB and BAS. These are the mnemonics which I was given when I dealt with change in pH of buffer solutions. Okay, this is the example for such type of problems. Okay, so it is the acidic buffer. It is the acidic buffer. For this buffer, what we add, what is the pH of a buffer solution when 0.2 molar HCl is added. So it is a acidic buffer and we are adding acid. We are adding acid. So what is the formula? What is the mnemonic? What is the mnemonic for acidic buffer? Acidic buffer, strong acid is added. Acid concentration increases. Acid concentration increases. Okay na? So first we calculate it is a acidic buffer, pH is equal to pKa plus log concentration of salt by log concentration of acid. Okay na? For this acidic buffer, when we add acid, what happens? Acid concentration increases. So pH changes. What is the pH change? pKa plus log concentration of salt. Here the acid concentration, that much concentration of acid increases and that much concentration of salt concentration decreases. So concentration of salt minus C by concentration of acid plus C. So this is the formula for calculating the pH when we add acid or base to acidic buffer or basic buffer. Okay, so first we shall calculate the pH before adding the acid. So before pH formula is pH is equal to, this is the formula for before pH. So pK is 4.747 plus log concentration of salt. Salt concentration is 1 molar and acid concentration is 1 molar. 1 by 1, that is 1. So 1 by 1, that is log 1, 0. So 1 by 1. So log 1 is 0. So pH is 4.747. That is the pH before adding the acid. Okay, and after the pH, let us calculate the pH after when we add acid or base. So when we add acid, what happens? Salt concentration, that much 0.2 molar concentration of HCl, and that much concentration decreases from the salt concentration and that much concentration increases in acid concentration, that is acid plus C. So after pH after acid addition is pH is equal to pK is 4.747 plus log concentration of salt is actually they given that the concentration of salt is 1 molar, and we are adding 0.2 molar HCl. So that much amount is decreased, 0.2 molar is decreased, and we are adding 0.2 molar acid, that much concentration is increased, Gg1 plus 0.2. So it is 4.74 plus log 1.02 1 minus 0. That gives 0.8, and it is 1.2. It is 1.2. So in the next step 4.74 plus log 0.8 it can be written as into 10 by 10, that gives 8 by 12. 8 by 12 it gives 2 fours 3 fours. Okay, so 4.74 plus log 2 minus log 3. So log 2 by 3, that is log 3. So pH is equal to 4.74 plus log 2 is 0.3, and log 3 value is 0.47. Log 3 value is 0.47. So when we add this 2 and subtracting this value, we get the pH of 4.57. We get the pH of 4.57. From this we can calculate the buffer capacity, because change in pH changes from initial pH is 4.747 and final pH is 4.57. So change in pH is 4.57 minus 4.74. So and number of moles that we are added is so buffer capacity, we can calculate the buffer capacity. Buffer capacity is equal to number of moles of acid, that is 0.2 by 4.74 minus 4.57. So it is 0.2 by 4.74 minus 4.57, that gives value what is 0.17, which is comes out to be 0.17, and the fraction is 0.2. It can be written as 20 by 17. Okay, 20 by 17, which gives 1.14, that gives 1.14. So buffer capacity is 1.14, and the change in pH and the buffer capacity, pH after adding 0.2 molar HCl is added. The formula for calculating the pH after we are adding acid or base, there are mnemonics. So you please try to solve the problems based on these mnemonics. Okay, so this is the only example for this type of problems. You can go through the several problems. Okay, so I hope these problems these are the problems by which we can understand the concepts. Basing on these problems, we are able to calculate the more complicated problems. Okay, I hope you all understand these problems. Thank you.